So once again, welcome, folks. Yeah, maybe we'll kick off. Yeah, it is like I just said a couple of minutes ago. This is another episode of YFTT Yugabyte Friday Tech Talks. It's a talk for engineers by engineers. So totally feel free to ask out or ask all those hard, difficult questions. Don't feel shy at all. We'd love to hear from you. Yeah, with that, maybe Bala, maybe quickly introduce yourself, your topic, and then we can get this show underway.
Sure. Thank you. Thank you so much, Karthik. Hello, everyone. My name is Bala, working as field engineer in India, Yugabyte Bangalore office. Yeah. So I'm going to talk about today, like how Yugabyte is going to extend the data lakehouse capabilities, and how are you going to really get the benefit out of Yugabyte CDC to the data lakehouse, and how you can build the apps which can support for all your analytics or all those sort of things. So that's the main agenda that we are going to talk about it, Karthik.
Awesome. Fantastic. Okay, let's get the show on the road then. Do you want to share your screen and kick off?
Sure. Yeah, thank you. Yeah, I hope my screen is visible.
Yes, you are visible.
Yeah, thank you. Yeah, as I said, the topic is going to cover more of the data lakehouse capabilities with YugabyteDB. As most of you know, YugabyteDB is having its own change data capture connector, which is really useful for to build a lot of change data capture applications and even to get the real-time data out of YugabyteDB. And like so knowing that, and we also thought of take today how it is going to be consumed at Azure Data Lake or Microsoft Fabric Lakehouse. So I'm just going to cover those use cases and topic, and then straight away going to some of the demos. So yeah. The real importance of like how Azure Data Lakehouse or Fabric integration is required today in the modern app world, right? So because Yugabyte being is one of the modernized DB which you are currently using it for all your cloud native applications. So it is also necessary that YugabyteDB needs to support the self-service AI, all those IoT streaming applications, and also the real-time operational analytics, like what the traditional databases are doing it today. The same functionalities, so that is even achievable through YugabyteDB by extending those change data capture feature. And it is also helping to build the applications. What is the data that is being persisted in the lakehouse? So where you can create more number of applications on top of that, the data which is comes from YugabyteDB in real time. And finally, you can just put the data for different purposes, like you want to send the feeds in the form of different files to further data dissemination purposes. So knowing these are all the main topics that why this is important for this integration. So we are just going to cover today the top three that you are seeing, the three hexagonal.
So top three, huh? Top three
Yes.
are what we're covering. Got it. Self-service AI, IoT, and real time. And this is all
Analytics.
the demos you have, right?
Yes, Karthik. So we have the demo for all these three.
Awesome.
Thank you. Yeah. So like we said, self-service AI and ML, which is part of the business analytics or data warehouse DNA for any of us today, which is mandatory for most of the organization for keeping the historical data, like how they can even do better visualization, better modeling, better prediction on all those things. So knowing that, like whatever data which comes to YugabyteDB on the left side, so which is going to be pushed to the Azure Data Lake through our DBCM Kafka Connect, what we have internally, right? So here again, we are not going to use any Kafka. We are directly pushing this to the Event Hub. Event Hub is acting as your message broker, which is continuously streaming the data from YugabyteDB and then pushing it to different data store, like what we mentioned here. It can be Azure Synapse, or it can be an Azure Data Lake, or it can even go to the other places of Azure, which is integratable with Event Hub. So as you can see the flow diagram, so this is the flow sequence is clearly saying the data is coming from the left. So and straight away, which is going to the Event Hub, which captures that. And 3 and 4 are more of Azure components, which takes care of your further processing and getting out of all the necessary things out of your Azure. So the more the importance here is like this self-service AI ML is not only going to help the application developers, the data engineers, the AI engineers, data scientists, who all are also consuming these YugabyteDB for various purposes in Azure. So that's the reason this self-service AI ML is one of the important use case today, like how that can be integrated with YugabyteDB.
Yeah, with all the generative AI going on, it's definitely important. So just to
Yeah,
reiterate, the purpose of YugabyteDB in this architecture is that you can collect data from a variety of different sources, whether it is a
right,
transaction application running or a streaming application, whatever it is, it will land in
right.
a one place, and then you can stream it out from there because you need a high throughput ingest, ability to read, all of that, right?
Absolutely, Karthik.
Got it.
Yeah, it can be any applications. Yeah.
Got it.
So
Makes
like you
sense.
mentioned, yeah, exactly.
The
It's
AI-based
not one
application.
specific. Yugabyte is meant for many different use
Yeah,
cases.
and
Yeah,
then you
yes,
can move it down and do something on it. Yeah, got it. Makes sense.
absolutely. Yeah, thank you. The second, the importance like is a very interesting use cases like IoT streaming and dashboard. As you all know, like YugabyteDB is very good for like a write intensive workload, which where it supports the two sort of APIs with YSQL and YCQL, where you can push the data to either in a native format, which is coming in JSON, or if it is coming with the proper structured format, you can put it in any place, right? So which is going to come from different sensors or devices or different gateways. So all these data are being continuously stored in YugabyteDB, where it can be like a reference data for those devices or a metadata for those devices, or even continuous transactions coming from those devices, like it's a events data, right? So where YugabyteDB is having its connector where it can even push this real-time streaming to your Azure Synapse or any other system which can do that. So here, where the role of YugabyteDB connector is important to even helpful for like a real-time data, which even needs an immediate analytics at your other end, where you can build a lot of analytics on top of it and all those things. So that's a more interesting use case where nowadays many of them are started consuming these architecture for building these with YugabyteDB. Yeah, so there are many use cases on top of that, like if it can be not necessary to be IoT sensor data, it can be even to a fleet performance analysis for a truck or car who can even continuously send those device data to YugabyteDB. Even you can find out like the driver's performance, the fuel card performance using those data. The third interesting point or the use case which we are going to cover here is like more of operational data analysis. This is even important for the traditional database, even supporting today like MIS reports or even BI reports. On top of that, even it needs to do a lot of analytics with that historical data, what is being mounted at your data lake. So this is again, we are going to take some of the logistic data. So like it's a trucks data or a taxi data, where it is going to continuously being stored in YugabyteDB through different applications, right? It is all going to be again microservices based apps, which is sending the data into YugabyteDB and it is getting sharded into YugabyteDB, and then where you immediately want this data also to the other side for consuming it with the for Azure Synapse and other things to predict the vehicle availability or even predict the fare, like how much is the fare now. So this is going to coming back to the transactional side of YugabyteDB, right? So that's more important, where people might be looking like, okay, I don't able to do my real-time analytics knowing that I'm not going to store more historical data in YugabyteDB, but I can still use my historical data store, what I kept it in the data lake. I can process it there because I can keep even more than 10 years worth of data and build my model, train the model. As soon as my test data goes from YugabyteDB, which is going to be evaluated the model, and that will take those score and calculate the prediction value, and then that will bring the predicted data back to YugabyteDB. This way, you will be getting both actual and predicted on the fly, and you can continuously use your app to get the predicted fare, predicted taxi, predicted availability. So and all those operational analytics that is required from this application itself from the transaction side, right? So that's very important today, where application don't want to rely heavily on only the data lake has to do. Even we will able to quickly get the data from you from anywhere and we can push it. So that's where exactly this role of YugabyteDB is, even getting those data back from Azure Synapse and pushing this to your applications.
Right. This is like an AI ML feature store, right? Like where you have the
Absolutely.
feature vector.
Absolutely.
Yeah, makes sense. Yeah, yeah, awesome.
Exactly. Yeah. Yeah. Thank you. So here I'm just going to cover like how the CDZ and Azure Synapse Sync architecture works. So as most of you know, we are having our Debizium Kafka connector, so which is having the Kafka API built in. So we already been tested our connectors with different message brokers like AWS MSK or Azure Event Hub or even Red Panda or open source Kafka, Apache Kafka, right? And again, we are able to sync the data to different consumption layer or consuming side. You can see clearly like it can store directly to Google BigQuery, or it can push it to Amazon Redshift or S3 or Elasticsearch or even Snowflake, right? So even more because because of the space I'm just putting left here, but we even tested with a lot of other connectors. Even it is really helping you to push it to any sync that is currently being available and compatible with these 4 connectors that are able to support it, right? The thing here is like there are a lot of new features being added into Yugabyte CDC today. Like we have metrics as available. You can even start track those loads, like how my loads are working, how much is the current capacity which is going. So all those different metrics, or even you can scrape it through the Prometheus, and you can dedicatedly build your dashboard for identifying how your CDC is also working from the left hand side when you are going to push this data, and accordingly you can tune it with the different parameters to see like how you want to push the data and all those things, right? So that's exactly the like this architecture really helping you to understand how the flow goes. So we are just following the same architecture here for this Azure Data Lakehouse. As you can see the left side. So again, YugabyteDB can be in cloud or on-prem, or it can be in your laptop. Even if you want to just to try it out this CDC connector for evaluation purpose. So you can straight away connect it through our connector that you can put it into the Kafka Connect, which we can push the data to Event Hub. That can trigger different pipelines within your Azure ecosystem, push it to the data lake and other Synapse Analytics storages, right? So this is a quick reference architecture. At least this will help you to understand how quick we can build it. It does not require any complex third-party tools or any other thing to push from YugabyteDB to Azure. It's very easy to just connect and do it. I'm going to demonstrate this also to see how you can quickly build it and doing it. Any questions, please, before I go to demo?
No, I think no questions. This sounds great. Let's look at the demo. It'll be awesome. And again, once again,
thank you.
if you have questions, please feel free to just type it in as a LinkedIn comment.
Thank you, Karthik. Yeah, so 3 demos we are just going to cover, just covering those 3 use cases. I will just go one by one. So before going there, so as most of you know, like Yugabyte Anywhere is the self-managed platform, which is going to help you to put the database cluster on your on-prem or your own cloud with the firewall enabled at your corporate firewall. So in this case, I have taken one of the cluster here, which is deployed in US East, as you can see the graph. So you can just see it here, right? So this is running in US East, which is a 3-node cluster. I'm going to use it for loading my data to this cluster. So this is what exactly currently it is going on. So I'm just using the sample app, which is already available in our Yugabyte samples. So whenever you get time, please play it around with this. This is the application, the market as op. I'm just using it. So let me just straight away start this application and see how the data is coming.
So this is going to send a bunch of market orders, like you're doing a stock trade or whatever, right? So something like that.
Exactly. Yeah, exactly. Yeah. So I'll stop this app. So just start it again. So this is a Node.js app, Karthik. As you said, it is just going to push the data from the pub market orders. This is the simulated data. So we are just getting those data from this pubnub and then pushing to YugabyteDB. So this is the data model. As you can see here, we have a let me just so you can see this is the tables that is currently used for this trade order. So this trade is one of the the table. So let me just get the data, what is coming from this trade table. Yeah, as you can see, this is all getting whatever you can see the left side, the application is pushing. Let's also see the application in the UI. So you can see this. Yeah, so this is getting streamed. You can see that this is all coming immediately. So this is just basically helping you to get those streamed data to just getting the top buyers and symbols and trades. So in the bottom, you can see all those streamed data which is coming from the application. So also you can monitor here. You can see the read and writes are happening. So you can also monitor in YugabyteDB like how this number of apps are happening and what is the latency and also the number of connections. Everything you can monitor from here. So this is exactly the table what I was just querying it and showing it to you, right? So yeah. Well, with that, I will go to the CDC portion now. How this data is going to be streamed and pushing it to the Azure Data Lake. Right? So for that, I will just keep my so what I used here. So this is the Kafka Connect I have used. So as you can see, this the configuration. So this basically telling you like how this is currently being configured. So let me just show the configuration file of what is this, the distributed connect distributed, this with this ei.h, which is the event hub. Yeah, as you can see, this is the configuration that you need to run your Kafka Connect, which is through your DBCM Kafka Connect. But we are not using any local Kafka here. So as you can see here, it is talking to the event hub what I created in Azure with these credentials. So again, this is all going to be encrypted. I'm using SSL. So with this, again, I'm supporting all these three protocol to make sure whatever data I want to just sending it from the application to the event hub, it is going to be encrypted. And then this is the place where I kept my the Yugabyte DBCM jar, right? So which is there in this place. So with that, I think we can straight away start the connector and see how we are able to see that. And before that, what I did it on the Azure side, like I created an event hub account, so which you can see from this side. So this is my event hub. This is just going to stream the data from YugabyteDB now, and you are going to get it. Again, this is a basic thing what we configured, and I already have my event hubs. So with all these topics are being tested. So now I'm going to use the same event hub, whatever I just shown in that configuration, right? So with that, I will just start it. Yeah, so it's starting now. So as you can see this, so this is let it go. So now I'm going to show what next to be done. So this is the market order application. So like what the currently the table name is the trade data, which I'm going to push it to event hub. So for that, I'm just creating this connector configuration, saying that these are all my Yugabyte database nodes, and this is the host name. Out of 5, I can just take one of the node. But again, this is all arbitrary. You can choose any name because it's like a we are using like a not a master slave architecture. It's a distributed and decentralized architecture where the leader can be in any node, right? So that's why we can choose any host name and you can put it. The credentials are there, the default credentials, and this is the topic name is going to come with this the table name, and these are all just for any other trading tables are there. I'm just going to bring it, and more important, this is the stream ID that we have to create it from this database where this table is there. So that's actually going to push these changes through the stream ID. So this stream ID is important as a metadata for us to track, like how the tablets are going to be even tagged to the stream ID. So we are just pushing those changes through the stream ID to event hub. So with that, I will straight away go and deploy this connector. So if you can just see that. So this is up now. So let's see this. Yeah, it's created. So it's successfully created. You can see the Kafka connector, what I deployed, it is continuously going. So yeah.
And now it's going to stream from the first order it got or from the new orders that it's getting?
Yeah, so the snapshot mode, I put it as never. So it is whatever data now it's going, it is going to start. If I put initial, yeah, if I switch it to initial, that will pull all the data from the first
row.
row.
That's fine. I was curious. So you have both options. Got it. Yeah.
Yes, exactly. Yeah, the snapshot mode will help us to take it.
Okay.
Yeah, this is very important for a large table, Karthik, because sometimes if it is a million records of the table are there in Yugabyte, it is difficult to push it in all in one go. Further, what we can suggest, like they can take out maybe a CSV file and they can push it directly to the system. Then they can start the real time from day one.
Yeah,
that is also a good option, right? Yeah. With that, I will go to now the event hub and let's see what's happening in the event hub. So whether I'm able to see that. Yes, as you can see, the messages are coming. So you can see the messages are coming and it is also going to the outside, which is saying the outgoing messages. That means the stream is coming. It is streaming is also going to the data lake. How it's going, I'm going to just show that also to you. Yeah. So let me just also show what topic that is currently this data is coming. So we have created the logical name in this configuration, which is DB server 35.trade. That's a table name. This is again a logical name. This you can just keep any name. So you can see that, yes, this is exactly the thing which is currently coming. So if I just refresh it, so it is just coming here. So let's go and see like how this data is being coming to the data lake, right? So as soon as you see, this is the Azure Synapse Analytics Studio. So in the Synapse Analytics, we have our data lake storage, which is being available as Gen 2. So here I'm just see like how this data is now coming to my event up to this side, right? So let me just go to the source. I'm just taking the market order data. Yes, this is a folder. So yeah, this is a trade, as you can see here. So now you can just see it's all coming. The latest data, as you can see, it is continuously streaming it, right? So this is exactly where the play is now. It's all coming in the Parquet format. Yeah, because the data, you can again put it to CSV or even Avro, whatever format you want to put it, that is doable through the code that you are going to consuming from your event hub. So it's a small portion of the code that we rotate to just to show you, like, so this is the market order app. I'm just going to show you.
One question, Bala. So here, so Ishwar asks, here in our YugabyteDB, after completing all data pre-processing, how can we choose the target fields? How can we choose the particular ML model? Because here we have different types and models.
Yeah. Once we identify the data, I think we will first send it to Azure. So where we need to do the future engineering at the Azure side to identify those fields are good for the model, Karthik, because it is because historical data will help you the quality of data, like where you want to really do some cleansing, because in operational store we may not able to cleanse it because we don't have that much quality checks, right? Because yeah, so it is better to do it on the other side. Yeah,
makes sense.
Yeah. So this is the topic, and then we are just saying this is the storage that we are pushing it, right? So as you can see that this is all just going to run it. Whenever I'm just running it, like this is just a Azure Spark pool PySpark code with just 2 lines. We can just write it and push it there. So with that, we are able to see like the data is now coming at the Azure Synapse, and easily we can see the data, right? How do I say that? So you can just see here, like we are also capturing the operations coming from Yugabyte, which is clearly carrying the create, update, delete. So these are all the flags is required for your data warehouse. So YugabyteDB is supplying those through this change data capture.
Change capture types. So what operation
yes.
to do, whether you want to, yeah, makes sense.
Exactly. Yeah. So you don't need to really worry how Yugabyte will tell me whether it is a new record or update record or this record deleted in YugabyteDB. So these flags will really help us to take the operations accordingly at our data warehouse. By if it is delete, you can even go for delete, or you can even leave it if you don't want to delete and you want to do a soft delete or something. Later you want to do a,
to Ishwar's question, I think here is where you will do whatever mapping you want, right? Like
yes, exactly.
Columns, drop column, you can do all of that here, Ishwar. Yeah. Okay.
Yeah, exactly. So this is just pushing the data to the data warehouse or the layer where you are going to build the analytics, Karthik. Yeah, absolutely right. Yeah, I can even pick and choose like what are all the fields are required. Let's say
the projection columns. Yeah, exactly. Yeah, makes sense.
Exactly. So I don't want all the columns, then I can just take only the relevant columns required for my model also. That's right. Yeah, so we can quickly run this so that you can see the data which is available here, and we can straight away go and see like whether the data is there or not. So you can see this trade event details, whatever I just put it. Let's run the query and see whether this is coming, right? So this way it is helping you to keep both your external table pointing to the data lake, which is not a physical table, which is directly reading like a link table, what is there in the Delta Lake format of Parquet. This is an internal table or a data warehouse table. What we just did the merge operations, that will be helping you to show. As you can clearly see, we have an operation C now, which is coming with an ID. So let me stop the app also and see like what is the data which is coming here. So let me just do it. Yeah. So let me just quickly run this. By the time it runs, I will just to show like how the BI data is coming here, right? So if I just yeah, this is the trade events what I just shown here. So like where you can just quickly run this. So this will not show with your operational, sorry. Yeah, so this will at least directly pick from the events table, which is there in the raw layer, and where you can see the operations are coming and see and all those things. So this is our actual table where you can even take from here, like how this is all even being synced from my data lake to my data warehouse table, which is going to be used, right? Here you don't see all those things. It will be straight away taking care of the operations, the change data capture operations at this table. So that's a basic difference of your staging layer to your the target table, whatever operations we performed now, right? If it gets updated in YugabyteDB, here also it gets updated. If it's been deleted, it is also deleted this side. If there is a new record, automatically a new record will come. So it's all gets streamed through YugabyteDB change data stream actually.
Makes sense. Yeah, fantastic. Yeah, fantastic. Awesome. This is great, man. This is great. And you can like, go do your thing downstream. And if this were like an AI feature store, right? I mean, like
absolutely.
And you do your analytics, your modeling, all of that stuff, push the weights back to YugabyteDB, and then you can get it in your online application, correct?
Absolutely. Yeah. So I can even build any sort of notebook where I can just build it on my own analysis also, so that those are all the features already built in here, so they can just pull it out, Karthik, easily. Yeah.
Fantastic. Fantastic.
Yeah. The second use case, I just want to quickly show it. So which is the IoT streaming use case. So knowing we have short of time, maybe I will quickly show like this data. I already brought it the same way here in the data lake, as you can see the folder. So where the source, again, we are just getting the IoT PubNub data, which is coming here, where you can clearly see that how this is all coming in again in the Parquet format. And this is again being ran through the same portion of the merge script, which is again helping you to identify the changes. So based on the elements, like whatever data coming from the IoT data, like it's carrying the event data, which is like event ID, sensor ID, the humidity, photo sensor, the different sensor values. So whatever you want to persist for the data lake analytics perspective, so those things can be persisted, and you can just use those fields for all the operations. It is important to see like how I can also quickly see my real-time dashboard, right? So many people may be thinking, okay, I also want to see, okay, whatever data is coming from YugabyteDB, I can build my quick and dirty dashboard here. I want to see whether this is coming or not. So I want to go by the sensor ID and see like what is the minimum ambient temperature, what is the radiation. So this is also getting refreshed in a minute or seconds. You can configure it. So this is again sourcing from the table what we are persisting in Synapse, and that can directly coming from YugabyteDB, right? So this is helping you to see like how your data is getting, and you can even share this dashboard to different user to see all those things. And this can be again consumed through your application directly, right? So all those things are even feasible with the second use case of having the real-time streaming through the IoT data, what is available in YugabyteDB through this universe. Actually,
awesome,
right?
fantastic. So one question that Jim asks, is there a way to see the intermediate JSON that was produced from the YugabyteDB CDC?
Yes, definitely we can see that. So I'm going to show that also. Yeah, if you see the so this is another the successor of Azure Synapse. So that also we tested, we are compatible. So this is called Microsoft Fabric, that is still in early stage or preview stage. So as you can see here, so this is the data preview, whatever data are coming from this. So you can see from this side, right? So like so this is the left side is the streaming. This is exactly the data what Jim might be interested. Like this is exactly the JSON format, the payload which is coming from Yugabyte to event hub actually.
Fantastic, fantastic. Hope that answers the question, Jim. This is great, Bala. This is fantastic. Really, really awesome demo. Very, very cool. The end-to-end value and how quickly you like
Yeah.
put it together.
Thank you, Karthik. Yeah,
Yeah.
thank you. So
All right.
the last use case, maybe I will quickly touch just for a minute. I will just close it with the analytics, which I talked about it. So many of you know, like we are using the yellow taxi data. So that again, we persisted in Yugabyte just to see like how I can even build a model, and I want to push this data back to Yugabyte, right? So this is this use case, you can take it for any operational data analytics, not necessary to be only the New York taxi data. It can be any data. So this is exactly where Ishwar was asking what field I'm interested to select it. I built the model and taken those logistic regression and calculated my score, and see this is exactly the ROC curve, which is telling the false positive and all those things. And finally, I'm pushing this data into a table, and I'm able to see this data back to my Yugabyte also. So for example, this is my yellow taxi fare prediction table. So this is again coming from Yugabyte here, right? Just you can see that. Okay, this is the passenger count, and what is the fare amount which is going from Yugabyte, the fare amount predicted because of the surge price based on various parameters. This is the predicted, so it's double the cost, right? So this is where application needs both these data that can be even consumed from Yugabyte, whatever they can consume it, so that they don't need to again create another service to get it from Azure, right? So we can automate this. So this will be feeding back the data to Yugabyte, where you can do YAML at other end, that YAML output can be put it to Yugabyte back. Yeah.
Awesome. Fantastic. Fantastic. Yeah, I think Jim says really great demo. I totally concur. Thanks a lot, Bala. I almost think we should follow this up with a more dedicated session, like, you know, with more time to explain all the demos and go through. Yes, right. But this is really, really good. Like, I think so. So folks, you know, no good deed goes unpunished. So we'll have Bala do a lot more work to explain this in a future webinar in greater detail. So
yeah, sure.
Piet says a good demo and useful concept plus tool. Want to read up on this? For example, in case of scale out, will the order of the transaction be kept guaranteed, or does the stream risk having order in different order in YugabyteDB source? I believe we have an option to either make it or not, right? So yeah.
So we have a flag in the configuration, the Kafka connector configurations to put the ordering also. Anyway, we are carrying the timestamp. Even we making sure the transactional consistency perspective, even the ordering is guaranteed. Karthik, that is definitely achievable.
You want to read up on this, for example, in okay, so fantastic, folks. Thanks a lot, Bala. This was really, really awesome. And thank you, everybody, for joining us. I think we'll wrap with that. Once again, if you have questions, feel free to post it on the LinkedIn comment box itself, or you can join our community Slack. You see it here, yugabyte.com/Slack. Go to the YFTT channel, and you know, we'll get back to you, and Bala will be looking at it too. All right, thank you, everybody, and once again, a special thanks to you, Bala. I know it's late for you, but it was still really good.
It's a pleasure, Karthik. Thank you so much. Thanks, everyone. Thank you.
Awesome. Thanks, folks.
Thank you.